Okay, very good morning to one and all. So, in continuation with the previous class, we had started with the design of the steel truss member, and from the previous classes, we we just finished the design of all the members of the truss, right? So we designed the top chord members, bottom chord members, as well as the remaining members of the truss. So in today's class, I'm going to tell you regarding the design of the joint. Like we'll be taking the joints, so we'll be designing only the joints, right? So in the exam, they will just specify you which are the joints you need to be designed. Okay. So I'll be just taking the design of one joint. Okay. And the design of a joint, again, it depends upon the load acting in those members to which the joint is connected. So the members which are meeting at that joint, the load carried by the member, that is the maximum load, we are going to design the joint for that maximum load. Okay, and the design of the joint includes finding the number of bolts which are required for the connection between the members and the joint. Okay, and if you are going for bolted connection, and if you are going for the welded type of connection, it is nothing but the length of the weld which you have to find out by assuming the size of the weld, and also by considering the thickness of that section which is meeting at that joint. Okay, so these are the two basic things which you are going to take when you are designing the joint. Okay, so we shall start up with the design of the joint. I'll be sharing my screen. Just confirm me whether it is visible or not. Yeah. Now is it visible? The screen is visible. Yes. Anybody? Emma, the screen is visible.
No, ma'am. Ha, ma'am. It's visible.
Okay. Okay. So if you look here into the figure of the class member, yes. So the design of a steel truss member, like I told, involves three important steps. That is, first the design of the members. We have already done it from the previous class. You go to, we had completed the design of all these
Ma'am,
members. Yeah. Yes.
ma'am, voice is not clear, ma'am.
And now check it clear. Hello.
No, ma'am. Voice is not clear, ma'am.
Is it so for others also?
Yes, ma'am, not clear, ma'am.
Yes. Now the voice is visible. Is it audible clearly?
Yes, ma'am.
Okay. So yeah, just confirm the screen is visible.
Yes, ma'am.
Okay. So if you look into the truss, the figure of this truss member which we have taken, so we had completed the design of all these members, which is the first criteria you should do, or which is the first step you should do while designing the truss member, right? And the second one is the design of the joints. So basically, the design of the joint, we are going to consider the end joints, because finally they will be resting on the column, right? So we'll be designing the joints at A and J, which are the same here since the truss is symmetrical. Okay, and the third and the final step is the detailing part. After the design of all these members as well as the joints, you have to draw the detailing of the truss member. Okay, so this will carry 50 marks for you because it is for 100 marks for your exam. So each design from the steel part will carry 50 marks. So this 50 marks will be divided into all this. That is the design of members, joints, as well as the detailing part. Okay, so in the under the design of the joint, we are going to design the joint A. Okay, I'll be just explaining the design of the joint by taking the bolted connection as well as the welded connection. Okay, the main basic thing when you are going for the bolted connection is finding out the number of bolts. Okay, for the highest load, or if the highest member load which is connected to that joint. Okay, you have to consider the highest load, that is the highest member force which is connected to that joint which you are designing. Okay, so at A will be designing the joint at A, as well as at C I'll be taking the I'll be designing the joint at C by taking the welded connection. So it is left to you whether you are going for the welded or whether you are going for the bolted. So like I told, in the bolted connection, you are going to calculate the number of bolts. So for that, you will be needing the maximum load, that is the maximum member load, as well as you will be needing the strength of one bolt. Okay, and when you are going for the welded type of connection, right? So there you have to find out the length of the weld. Okay, you have to assume the size and you have to calculate the thickness, right? And you have to throw thickness and then you have to find out the length of the weld. That will be under the welded connection. Okay, I will be taking these two type of connections and I will be separately designing the two number of joints. So we shall begin with the joint A now. Okay, so the first thing what I have already just told you, the design of the joints.
Ma'am,
Yeah.
ma'am, Microsoft screen is visible, ma'am, but PDF is not visible.
Yes. Okay, I'll be sharing it again. Yes, now can you see the PDF? Can you see my notes?
No, ma'am.
Okay. Now can you see my notes?
Yes, ma'am.
Okay, I'm sharing my screen. Can you see my notes PDF? Yes. My notes is visible for you PDF.
No, ma'am. No, ma'am.
See, some are telling yes and some are telling no.
Ma'am,
See,
screen
you
is visible,
Screen
but
is
no
visible, ma'am,
sound.
but PDF is not visible.
have now see.
No, ma'am.
Yes. Now check it whether the notes is visible. Whether my PDF notes is visible now.
No, ma'am. Ha, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, now is it visible?
Yes, ma'am.
Hello, is it audible?
Yes,
Yes,
ma'am.
ma'am.
Okay, now just confirm me whether my notes is visible or not.
Yes, ma'am. It's visible.
Yes, ma'am.
Okay, okay, okay. So, like I told, so the design of the joint involves the first you have to consider what are the different types of members which is associated with that joint. So if I take joint A, okay, so if you see this figure, okay, at joint A, so it is a member AB and it is a member AE. So you have two members. So you have to write down what are the maximum forces in member AB and member AE. So the maximum member forces you have to be considering is the factored member forces. Okay, you have to multiply it with 1.5, right? So, okay. So the members AB and AE meet at this joint. So the maximum factored force in member AB. So you have to open the load table, right? So member AB, the maximum force. So if you take member AB, there are two forces which we have already classified under the compression and tension. So irrespective of compression or tension, you have to consider the maximum load. So between these two, the maximum load is 36.17 kilonewton. That is what? That is the maximum member force in member AB. Okay. So this is the service force or the service load. Similarly, EA or AE. So what is the maximum load? It is 32.21. Okay. So AE, it is in the design compression load is 18.84, whereas the tension force is 32.21. The maximum of these two is 32.21, right? So we have to write down these two forces, right? Maximum factored force in member AB, that is from the load table, we got the value, maximum load value as 36.17. The factored will be 1.5 times of 36.17, which is 54.25 kilonewton, right? And similarly, the maximum force in member AE. So we got the maximum force in the member AE as 32.21. So we'll be converting it to the factored load, which is 1.5 times of 32.21, which is 48.31 kilonewton, right? Any doubt here? So we have got two forces. Okay, two of the maximum forces in AB and EA respectively, which are 54.25 and 48.31, right? Any doubt? Raise your hand if you have understood it. Just go through this one. Yes? Okay. Now, what is the maximum load now? So the members which are acting at the joint are AB and EA or AE, right? So the maximum force to which we have to design the joint is the highest load between these two members, because those two members are joining at the joint A, right? So it is 54.25. So we have to find out how many number of bolts are required for the factored load of 54.25. So, like you know, the number of bolts is calculated as the ratio of the factored load which is acting at that joint, right? Divided by the strength of one bolt. Okay? Which in turn, the strength of the bolt is calculated as the minimum value of the strength in shear as well as in bearing. So we have to consider the strength of the bolt, right? The strength of the bolt, which is less than the strength in shear as well as the bearing, right? So for that, we require what is the thickness of the gusset plate as well as what is the diameter of the bolt we are assuming. It is the designing, so we have to assume the diameter of the bolt. From that diameter, we have to calculate the diameter of the bolt hole. And what is the thickness of the plate which is used for the connection? That is nothing but the thickness of the gusset plate. So let us assume, so you have to assume these two parameters before going into the calculation of the design strength of bolt. Okay, so I'll be assuming with 16 mm diameter bolts. Okay, so using or assuming 16 mm dia bolts, and we are assuming here black bolts, right? So we are not assuming friction type of bolts, we are assuming the black bolts, right? And the diameter of the bolt, what is assumed is 16 mm. Okay, and for 16 mm as per IS 800 2007, the clearance given for 16 mm dia bolts is 2 mm, which makes it to 16 plus 2 as 18 mm as the diameter of the bolt hole, right? So the diameter of the bolt hole is 18 mm. Okay, and you can write that one here. Okay, and the thickness of the gusset plate assumed is, you can either assume 8 mm or 10 mm also. So I am starting with the basic, that is the smallest thickness, it is 6 mm. So using 16 mm diameter bolts and the 6 mm thickness gusset plate is used, we shall see the design strength of bolt. So the design strength of bolt is nothing but the strength of the bolt in shear as well as in the bearing, right? So what is the strength, shear strength of the bolt? It is given as Fu by root 3 into Nn plus Anb plus Ns into Asb by gamma m naught, which is 1.25. Okay, so this is the basic formula for the strength of the bolt in shear or the shear strength of the bolt. So let me tell you one thing which is very important here. Like, we know we have designed, so if you consider this joint A, yeah, okay, if you consider this joint A, AB and A are the members which are acting at joint A. So if you just recall the design of the member AB and AE, which are top chord and bottom chord member respectively, we had designed AB, that is top chord member, as double angle section, as also we have designed AE, which is the bottom chord member, as double angle section also, right? We had designed these two members as the double angle sections, which makes the bolts are in double shear, right? So we have designed AB and AE as the double angle sections. Okay, so when the sections are double angle section, the bolts used for the connection will be in double shear, right? That makes us Nn plus Ns equal to 2, right? So Nn plus Ns equal to 2. So there are two shear planes. So assuming each shear plane is passing through thread as well as the shank portion, so Nn will be equal to 1 and Ns will be equal to 1. Okay, when we add these two, Nn plus Ns will be equal to 2, which signifies the bolts are in double shear. Yes, hope everybody is remaining the basic thing, right? So now calculate the shear strength of the bolt in double shear, right? So I'll be taking Nn as 1 and Ns as also 1. So it will be 400 by root 3. So you can just write down a sentence here also while assuming the diameter of the bolt. So assuming 16 mm diameter bolts of grade 4.6. So we'll be assuming the black bolts of grade 4.6, which makes the ultimate strength of the bolt, that is Fu as 400 Newton per mm square. For 4.6, Fu is 400 Newton per mm square, right? So 400 by root 3 into Nn is 1 into 0.78 times of pi by 4 into 16 square plus pi by 4 into 16 square into 1. That is Cnn divided by 1.25. You will be getting 66.12 kilonewton. This is the strength of the bolt in double shear, right? And in bearing, it is 2.5 kb into d into t into fu, where kb is the least value. Calculate it. So we will be getting the least value of kb as 0.675. kb is the least value of E divided by 3d naught, P divided by 3d naught minus 0.25, FUB by FU or 1, right? So depending upon the diameter of the bolt, so assume the edge distance E and the pitch P and calculate the KB value. Okay, so we will be getting the KB value as 0.675. All right. So substituting in the bearing strength equation, that is 2.5 into 0.675 into diameter is 16 into thickness is 6. So how you got the thickness? It is the thickness of the gusset plate into 410. Okay, we will be getting 66.42 kilonewton. So you have got the strength of the bolt in shear as 66.12 and strength of the bolt in bearing as 66.42. So the strength of the bolt is minimum of these two values, which is 66.12 kilonewton. Right? As any doubt here? Just go through this. Okay, any doubt? Just raise your hand if you have understood, so that I will continue with the further design. You can just go through the steps. Okay. So now we have got the strength of the bolt. Now to calculate the number of bolts, it is nothing but the factored load divided by strength of one bolt. Factored load is 54.25 divided by 66.12. So you will be getting one smaller value, that is in terms of 0. So let us round it off and take it as 1. So you will be getting one number of bolts, right? So one number of bolt. So usually the minimum number of bolts provided for the joints in the truss member is 2. Remember, the minimum number of bolts required is 2, right? So we will be taking minimum of 2 number of bolts for the connection. So you require 2 number of bolts. Like if you just look into this figure, so for the connection of AB for the at joint A and connection of member A at joint A, you require 2 number of bolts respectively for the 2 members. Okay. So this is the design of the joint A. Any doubt here? Okay, just go through this. Okay, shall I go to the design of the next joint? Right? Any doubt? Okay. So now moving on to the joint B. So see, the usually only one joint will be asked in the exam, design of one joint. So I'll be just designing randomly 2 to 3 joints here. So I have designed the joint A. Now going to the joint B, I'll be designing joint C by the welded connection. When you are going for the welded connection, how to design the joint, I'll be telling with respect to joint C, right? So now going to joint B. So if you see here, so joint B, what are the members which are associated with joint B? It is the member AB, right? Member EB, right? And member CB, right? So 3 members are connected at joint B. So you have to consider the highest load, factored load in member AB. So if you consider AB, it is the, so we will be converting it to factored load later. So let us just see what is the maximum force in member AB. It is 36.17, right? And in what is the other member? It is EB. So in EB, the maximum load is 6.95, right? And in CB, so CB, so it is 29.24, right? So AB, BC or CB and BE. So AB it is 36.17 and BC it is 29.24 and EB that is 6.95. So if you look carefully, the load in the top chord members is higher compared to these intermediate members. So only we are designing the top as well as bottom chord members as the double angle section. Okay. So now let us write down all these values of the maximum forces in all these three members. Okay. So the factored load in member AB is 54.25. If you multiply it with 32.25 by 1.5, right? And the factored load in member BC, so the maximum load was 29.24. The factored load will be 43.86. Okay. And the factored load in member EB, so the maximum load was 6.95, which is very low compared to these two forces, right? So the factored load will be 10.42. Okay. The component of the force in member AB in the direction of members AB and BC being very small, right? So if you look here, all these three values, so the force, the factored force in member AB is comparatively very small compared to the factored forces in other two members, that is 54.25 and 43.86. So we'll be, however, compared to these two forces, we have got still more lesser value, that is 10.42. So if you look here, for 54.25 only we got the less number of bolts. So for 10.42 we'll be getting still more lesser value. So we'll be assuming minimum of 2 number of bolts for all the connections, right? So 54.25 we have already designed here, that is a joint A. So there also the maximum force was 54.25. So for 54.25 only we got the number of bolts to be less than 1. But if you look into these three values, the lesser value is 10.42, which is comparatively very less than the forces in these two members. Yes or no? So for that purpose, we'll be providing minimum 2 number of bolts for all these connections. So like that you have to write the sentence. So I'll be providing 2 number of bolts in AB, BC and AB at the junction B. So for D also, if you look here, for D also you can see the number of bolts provided will be 2, because the force is very less compared to the, so for D the force is very less compared to the member in DC and DE. Okay, this one, it is symmetrical, it remains the same, right? So providing minimum number of 2 bolts in the member AB, BC and AB. In the similar way for joint D also. So in CD the load is more, whereas in DE the load is less. So for the lesser value of the load, we'll be providing 2 number of bolts. So where all the D is connected, that is, if you look here, so D is connected to DC, so DE, DF and DG, you will be providing 2 number of bolts for this joint. Okay, so this is regarding the design of joint when you are going for the bolted type of connection, right? Any doubt here? You can just go through these notes. Just go through this. Any doubt? Raise your hand if you have understood. So till this joint A and B, I have designed it when we are taking the bolted type of connection. So I'll be taking the joint C and I will be explaining how the joint is designed when you go for the welded type of connection. Okay. Okay. So this welded type of connection I'll be explaining in the next class, because it will take still more time. Okay. So only thing, just remember, so when you are going for the bolted type of connection, the design involves calculation of number of bolts. Okay. And for the welded connection, the design of the welded type of connection for the joint involves the calculation of the length of the weld. Okay, so to get length of the weld, you require the size of the weld, right, which is 0.7 times of the throat thickness, and for that you should assume the size, okay, minimum size of the weld, and taking into account the design strength of the weld as well as the size, you will be calculating LW, which is the length of the weld. Okay, so it is also simple. Just you should be knowing the difference between the bolt as well as welded connection, what exactly bolted connection you are going to do and for the welded connection you are going to do. So after this I'll be designing the connection at A. So if you look here, so what all connections are required at A when it is resting on the column. Okay, and later we'll move on to the detailing part. You have to draw the detailing part of the steel truss member, and with that the design will be finished. Okay, any doubt here? Okay, no doubts.